Okay, with this question we need to actually find three things. We need to find the Cartesian equation, the domain, and that's all in part one. And they would like a sketch in the second part, so it's something we should be able to draw. Now, often they'll do that with these where you've got an ellipse, like you saw in the introductory ones. You can draw an ellipse once you know where the centre is and once you know where what the axes were in both directions. With this one, the nature of the equation is a little more complicated, so we'll see what the result is of the first part and then see what the conclusion can be. Now, what we're looking for, first of all, is some sort of relationship that will link cot and cosec. And the cot-cosec one is that identity. So we need to know what cot squared is, and we need to know what cosec squared is. So cot squared of t, move the 2 to the other side and square it. And the cosec squared is just a rearrangement on the y. It's y plus 2. So what we can do is we can now use the identity to create our equation. So 1 plus x minus 2 all squared is equal to y plus 2. Expand and rearrange, so we get x squared minus 4x plus 4 plus 1 minus 2 is y. So we now get an equation x squared minus 4x plus 3, and that is my function fx that they were asking for. Second part there is they'd like to work out what the domain is. So the domain is what's happening for x. So we've got x is 1 over tan t plus 2. And we're doing it for what happens when the range for 0 pi to pi. So tan in that range, tan for 0 less than or equal to t less than or equal to pi, tan of t. If we have a look at the output from this function, and the output for that function in the region, tan goes from there up to infinity at pi over 2, and then comes back down and in for pi radians. So the tan has a range of all real numbers, so therefore 1 over that will have all real numbers. So this leads to x belongs to all real numbers, or from minus infinity to plus infinity, but strictly should be all real numbers. So tan t is all real numbers, so if they're all real numbers plus 2 is still all real numbers. So now we're looking for the sketch. And the sketch for this is quadratic, so of course we can actually do quadratic sketches relatively easily. Let's pull out quickly the sections you need. So where's my drawing? Let's draw some axes. Starting with the function. In the form it's been given, we know our y-intercept. So the 3 gives me my y-intercept is 3. If I factorise it, so x squared minus 4x plus 3 factorises into x, 3, 1, both of them the same sign, so they're both negative, so we're going to go through 1 and 3. And you may not remember this one, but you can also do completing the square to find the minimum point. So if I can get x minus 2 squared, subtract off 4 from minus 2 squared, which is too much, plus 3, and this gives me a position x minus 2 squared minus minus 1. And that tells me that the coordinates are reverse the sign inside the x function, because this isn't parametric, and keep the sign on the y direction. So it's going to go through the point 2 minus 1. There's my coordinates. We know it's a parabola from the x squared. So there we go, we can draw a graph through the point showing where it meets the axes all the way through. And it should go through that one as well. Another way to find this point is also if you've got pairs of points on a parabola, there is a line of symmetry. Just make sure my axes are labelled up properly. 3, 1, 3, y. Show the intercepts. You might even want to show that point as being 2 minus 1 to show all the components you could do. And that's how you can draw the parabolic curve. Okay, I think between these two videos that should be sufficient. If you need help, make sure you ask me and follow up.